real-life equation. We've seen something like this before, haven't we? We had 1 over f, I think is what we called it before. But this is 1 over a. Is it this one, Gabby? 1 over b?
No.
I'm confused then. Now we're in the right spot. Can you tell me what's the first thing you need to find? Yeah.
Common denominator.
Least, common denominator is fine. Least common denominator would be best because you can make the common denominator as big as you want theoretically. You want the least common denominator, right? So least common denominator for this is going to be what?
17.
Yeah, the least common denominator is 17. Another thing to find right now, just get into the practice of doing it. It's helpful. Find the domain. Can someone tell me what the domain of this function is or this equation is? What's the domain going to be? Gabby. No. Can
Wait.
No. That's not the domain. Can someone tell me what the domain is? Noah.
X such as X. That doesn't equal
Does
0.
not equal 0. Does not equal 0. It's everything besides 0. So why do you find the domain? What's the point?
Make sure the answer that you get in the end
Is in the domain, right? So like for example, let's say we solve this and it's not, but let's say we got to the answer 0. Is that in the domain?
No.
No. So in that case, there would be no solution. Yes.
So
After we have the LCD, what do we do now?
you
Multiply
multiply
what?
the things by those.
What do you mean the thing? All of the things is what I want you to say. So you take this 7t and you multiply it where? There, and there. A lot of theirs. So we have 5 over 7t times 7t equals 52 over 7 times 7t minus 3 over t times.
7t over 1.
And do a lot of things cancel?
Yes.
That's the whole point. 7t goes away, the 7 goes away, and the t goes away. So what are you left with?
52. Oh.
Try again.
5 times 7.
Which is?
35.
35 equals
52t
52t. Yeah, I'm going to write that a little better. It's not that. 52t, yep.
minus 21t.
21. The t canceled.
Oh.
The t.
Okay.
T canceled there. So what do I add to both sides?
21.
So you end up with 56 is equal to 52t. Now what do I divide both sides by? 52. So I get t is equal to 56 over. Simplify that fraction. What's half of 56? 28. What's half of 52?
26.
Half it again. 14 over 13. That would be your final answer right there. Now we're not solving this, right? Because there's no equal sign. We're just simplifying. What kind of fraction is this? What kind of fraction is this? It's a certain kind of rational function. It's a complex fraction. Why is it a complex fraction? Fractions in the fraction. Right. So how do you attack these? What do you do? How do you attack these? You attack them.
One at a time.
Yeah. What do you mean one at a time? Explain that.
So you want to simplify the one on the top.
You simplify the top and the bottom separately and then go for it, right? So if you look at the top here, how are you going to subtract those two things? What do you need to find? You need to build a common denominator. So what are we going to multiply this 1 over x by?
X plus 1 over x plus 1.
Exactly. And what are we going to, it's x plus 1 over x plus 1. What are we going to multiply this one by?
X over X.
X over x. So what do we end up with on top? 6x minus x plus 1 over, what's the common denominator here? X times x plus 1 is the common denominator there. All over, what do we multiply 2 over x by?
X plus 1 over x plus 1.
Gets pretty repetitive after a while, doesn't it? And what's this one get multiplied by?
X over X.
X over x. So you end up with 2 times x plus 1 minus 4x all over what? Exactly. Now we have one fraction on top and bottom. That is our first goal. We really want to get one fraction on the top and one on the bottom. Why? Now what can we do?
Multiply by the reciprocal.
Yeah, instead of dividing by a fraction, we turn it into multiplying it by a what? By the reciprocal. So x times x plus 1 over what? 2 times x plus 1 minus 4x. What cancels there?
X plus 1.
And what? So this x plus 1 cancels. What else cancels? And the x's.
And the x plus 1.
Nope, because there's a minus sign.
Oh, yeah.
So what do you end up with here? Because these are like separate things right here.
6 minus
6x minus x minus 1 over what?
2x.
Plus 2 minus.
4.
Are we done?
No.
No.
But I like to
So 5x minus 1 over what?
2x.
Negative 2x plus 2. Boom. What to do first? What's the best first step? Someone say it. Factor. Need to factor. So factor, there are three, actually all four of these things can get factored. All four of them. At least I think so.
Yeah.
Okay, what is the top one factor in top left? B plus 3, B minus 2. What is this going to be? Plus 4, B minus 2. What's this one?
B plus 4.
2B plus 4 is, yep. And what do you factor out of the bottom here?
3.
B plus. Cancel the easy things. B plus 4, B plus 4, B plus 4, B plus 4, B minus 2, B minus 2, and what is left?
Alright, that was so much.
No, hold on. To be clear here, the reason that was so easy was because we just flew through the factoring because I was jockeying. This is what I...
3 over 3. Yeah.
Oh, look at that. And I wrote the answer wrong. B plus 3 over 3.
You can't cancel.
No, because it's a plus at top. If it was B times 3 over 3, you could cancel it, but it's B plus 3 over 3. No canceling. No canceling. Think about it this way. Whenever you want to understand why that's the case, think about it this way. 1 plus 2 over 2, is that true? No. See what I mean? Think of a specific example. Solving for P. You can cross multiply, sure. You could cancel first. Like, how many 50s are there in 300?
6.
6 of them. That cancels, that makes it 6. What's 9 over 6? 3 over 2. So that whole left side simplifies to 3 over 2. What's half of 8? What's half of 350? Come on. 175, right? I like simplifying the fractions first. Now, can we cross multiply? 4 gets multiplied by what? Well, 4p gets multiplied by what?
2.
2. So what's 4p times 2?
8.
So you have 8p equals 3 times what? 175. So the answer to this is p equals 3 times 175 all over 8.
You don't have to do it that way.
You could. The rate for Cheryl is r, for example, whatever you want to call it, but for Bill it's going to be r plus 1 because he's on the sidewalk, right?
Yeah.
The time for this one is going to, what did you call it? T and t minus 50. So what's the relationship between distance, rate, and time? Distance equals rate times time. So if you take the three things here, you know it's 300 is equal to RT. What about the next line? 300 is equal to R plus 1 times T minus 50. So how many equations do you see right there? How many equations do you see? 2 equations. How many variables?
2.
If you have 2 equations and 2 variables, theoretically you can solve it, and you want to think to yourself, we're in rational function land, so we should probably work with rational functions. So you have 300 is equal to RT, and 300 is equal to R plus 1 times T minus 50. What can you isolate right here? What could you isolate?
R or T.
Excellent answer. R or T. What do you want to isolate?
Let's isolate R.
If we isolate R, can someone tell me what R equals other than Hannah? What does R equal if you isolate?
Minus 300.
No. Take a look at the board and tell me what R equals.
300 divided by t.
Yes. 300 divided by what?
T.
T. Raise your hand if you understand where the 300 divided by T came from. So now what do you do with this?
Plug it in.
Plug it in right there. So you have 300 is equal to 300 over T plus 1 times what? T minus what?
50.
50. How many equations is that?
2.
1. How many equations is that? 1. How many variables is that?
1.
Okay, everybody.
We had a 50-50.
And we got 300 is equal to R plus 1 times T minus 50. Kind of makes sense because if the rate gets faster, the time should go down because they're going the same distance, right? So we're plugging this in. We need to distribute at this point. If we take this right here and multiply it over to that, what happens when I do that? 300 over T times what? T. And then we take this and we end up with minus what? 300 over T times what? Well, I did the minus right there. Times 50. Correct. And then that's the first two terms. What's next? Plus what?
T.
T. That's this multiplication right here.
Minus 50.
Minus what?
50.
50. So can we clean this up?
Yeah.
I hope so. What cancels?
The T.
This cancels right there. Let's keep going here and see what happens. We get 300 is equal to what?
300.
Minus, what's 300 times 50? There you go. Plus t minus what?
50.
What can I cancel?
300 times 50 is 1,500.
15,000. Thank you. There it is. What can I cancel on both sides?
300.
Yeah, the 300s goes away, right?
Yeah.
Hey, look. It goes away. So you have 0 is equal to negative 15,000 over what?
T.
Plus
Plus T
minus
minus 50.
50. When we solve this, everybody, we're going to get t. T is the time, right? Once we get t, we can use that to get r. We absolutely can get that. It's just going to be a bigger number. We could have tried to solve for r if we wanted to. At this point, what do you think you need to do at this point?
Add 50 to both sides.
No. Good idea, though. You could. That's you could do that, but it's not going to help you. Anybody want to guess? We don't like fractions. So what are we going to do? Verb. Give me a verb. Multiply everything by t. If I multiply everything by t, what does the left-hand side stay? 0. What's 0 times t?
0.
What's the next term become?
50.
Negative 15,000. What's the next term become?
T squared.
T squared. And what's the next one become?
250.
50t. What kind of equation is that?
The one where you
T squared minus 50t minus 15,000. Is that a quadratic?
Yeah.
Yes. Now here's the thing, Gabby Record. I understand, but my question is, does this look like a fun thing to have to solve?
No.
Why not? Can someone tell me why clearly that does not look like a fun thing to solve? Sadea.
Because, oh wait, no, I never mind.
Okay, someone tell me why it does not look like a fun thing to solve. Noah.
Because the numbers are so big.
Big numbers make it not so much fun, right? There's a lot of factors for 15,000, right? They have to be decently close together. Hey, at least it's 1 right there. I think someone was going to say that, and then oh, it is 1. Oh, wait, 15,000. So we're going to pause here and say, okay, so let's say we didn't want to factor this, and we're like, I really don't know. Let's go back to the beginning here. This question was asking us to find the rate, correct?
Yeah.
So our first step here was we could choose, do we solve for r or do we solve for
For T.
or t?
Yeah.
We could decide, do we want to solve for r or do we want to solve for t? This is all correct. I'm not saying it's wrong. I'm just saying that this right here is a little bit hard.
Yeah.
We could, if we wanted to, solve for r. I want to point out a different order of how to do this that was really great, which Sadea worked on over there. She did this. So here's one equation. 300 was equal to RT, right?
Yeah.
And 300 was also equal to r plus 1 times what? T minus 50, right?
Yeah.
Something like that. What Sadea did, which I really, really liked, was she isolated t. She isolated t. So what does t equal in this case? T is equal to 300 over r. Is that correct?
Yeah.
Yeah, that's pretty cool. Okay. So we go down, we do that kind of the same thing over here. We know that t minus 50 is equal to what? 300 over what?
Over
r plus 1.
Plus 1.
You divide by this. Let's take a look at these two things right here. You see this? What does the top one tell us t is equal to? 300 over r.
Yeah.
Where can we plug that in?
And
Into the bottom. So watch. So you get 300 over r.
Yeah.
So this, just to be clear, everybody, this right here, where did it go?
Yeah.
This is all the same, right? But what do we still have left? Minus what?
50.
50 is equal to
300 over
r plus 1. All of this work we did before is fine, but it's not super easy.
Yeah.
Let's go back over here and look at this. Oh, what should I multiply everything by at this point?
R plus 1.
Times,
Oh,
what is
times r.
what is the LCD?
R plus 1 times R.
The LCD here is r times r plus 1. So what do you do with this LCD? You multiply everything by it, and you end up with 300 times r plus 1 minus 50 times r times r plus 1 equals 300 times r, because the r plus 1 cancels.
Yeah.
Hey, are there any fractions left?
No.
No. So what do you have to do at this point? What do you have to do?
Distribute.
You have to distribute 300r plus 300 minus 50. I'm just going to leave it like this for now and do it one at a time. Equals what? Hey, what cancels on both sides? This seems like it might be better than what we did before. We have 300 minus 50r squared minus equals. What can I divide everything by at this point?
It's minus 50R, not
Yeah.
minus 50.
Minus 50.
For the plus.
Oh, it's 50r. Thank you. What can I divide all those numbers by?
50?
Yeah, you sure can. Good job. What's 300 divided by 50?
6.
So we're dividing this whole thing by what?
50.
Because if you can divide everything, it's the same thing on both sides.
Yeah.
300 divided by 50 is 6 minus
R squared.
minus
R.
equals.
0.
Is this in the right order? Do we like having this in that order? No. What order do we like having it in?
R squared. Descending.
Descending power. So what's the first term going to be?
R.
Nope. Negative r squared. Exactly.
R
Minus r plus 6. Do we like that negative out front?
No.
So what should we factor out first?
Negative.
Negative r squared
Plus.
plus r what?
Minus 6.
Equals. So now we have negative r. Oh, we have to factor now. Can someone raise your hand when you see what it should be factored into? Raise your hand when you see what it should be factored into. So what are the two? So r plus 3 is equal to 0 or what?
R minus 2.
So r is equal to negative 3 or r is equal to 2. Which one does it have to be?
2.
Why?
Because you can't, with this time problem, you can't have a negative rate.
Yeah, you better, the negative rate, we're not like going backwards. So what's the rate? What's the rate that we're asking for here? The rate, let's go back to the beginning of this problem. This is the rate that they are what?
Walking.
Walking at. So
And then
they're
there's 1
walking,
meter
so Leia,
faster.
what's this asking here? It's asking, what is their walking rate? Their walking rate is this r. That is the walking rate?
And then he's going 1 meter faster.
Correct, 1 meter per second. So the final answer to this would be 2 meters per second. This is a challenging problem. It absolutely is.